Hello viewers, so we have this question that says prove that the following equation is dimensionally consistent. Now the equation we have is t is equal to 2 pi the square root of L over G. As usual, to prove that a formula is dimensionally consistent, we need to check the dimensions on the left hand side and compare them with the dimensions on the right hand side. If the dimensions are equal, it implies to say our formula is dimensionally consistent. So let's check that. Let's start with the left hand side. So we'll start with the left hand side. Let's have the left hand side here. So on the left hand side, we have t. T is period. So whenever you see capital T, we're talking about period in physics. So T is period, and period is just time taken for one complete cycle or one complete oscillation. So it's measured in the units of seconds. So the units are seconds, and seconds is basically time. So the dimensions on the left hand side for T, we have time. So the dimensions for period is just T, like that. So on the left hand side, we have T. Let's check on the right hand side. So we have the right hand side here. So on the right hand side, we have 2 pi square root of L over G. Now 2 pi is a constant, 2 is a constant, pi is a constant. So here we don't consider any constants. When you're dealing with dimension analysis, no constants are considered. So we are just focusing on the square root of L over G. This is equal to L. L is length, so it's measured in meters. So we have meters down there, and then down here we have G. G is acceleration due to gravity. So acceleration due to gravity is still acceleration, so it's measured in meters per square second. So this is basically what we have in there in the square root. So we can do this in this format. What we have there is the same as the square root of, I'll say m, that is basically divided by m, that is dividing by the square of the seconds. So we have m divided by m per square second. When we do our simple mathematics here, you find that we're going to have m, we change the division to multiplication, and we'll have our s squared there divided by m there. So that's what we have inside there. Looking at what we have, you see that this m and that m will basically cancel. So what we have in the square root now, this will be equal to, in the square root, we'll just have s to the power of 2. All right. Now that we have s to the power of 2, square root is the same as the power of half. So what we have here is s squared to the power of 1 over 2. So whenever you see square root, the square root of something is just like that number given to the power of. If you say the square root of 2 is the same as 2 to the power of half. So we have s squared to the power of half. Now, when you have a power that is given to a power again, what you do is you just multiply those powers. So what we have here is we have s, this will be to the power of 2 multiplied by 1 over 2. So we can see 2 and 2 will cancel here, and this will give us s. 2 by 1 is 2. 2 divided by 2 is 1. So this is s to the power of s to the power of 1 is the same as s, and s is the unit of seconds of time, which is seconds, and then the dimension is basically just t. So we have a t there on the right hand side. So we can see that we have the same dimensions on the left hand side as we have on the right hand side. It implies to say our formula is dimensionally correct.